Good morning or afternoon, whichever it may be. Maybe it's even evening. Today, though, we are going to learn a little bit about probability. We're going to start going into probability and statistics. I like to start with the probability first before we do statistics. But probability is just the chance of a event happening. To give us a feel for it, I'm going to start with the six-sided die. Here you see a six-sided die. Now, one thing about simple probability, and we're going to just do simple probability. Today's assignment will be EE1, probability of simple events. Simple events basically mean every event has just as likely chance of happening as every other event. So if you rolled a six-sided die, it's just as likely you're going to roll a 1 as it will be to roll a 2 or a 3 or a 4 or a 5 or a 6, right? Each chance is just as likely to happen as any of the other events. And so all of those events, all those is called the sample space. So the sample space would be the 6 different outcomes. So if I roll a six-sided dice, I could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So I have 6 possible outcomes. Now, when we talk about probability, we want to know what's the probability of one or more of certain of these things happening. The way they designate that is they'll use a capital P for probability. Next to that, they'll put parentheses in what they want to know the probability of. So for instance, in rolling this six-sided dice, I may want to know the probability of rolling a 3. Well, to find or calculate probability, it's not very difficult. It's as long as it's simple probability, where each event is just as likely to happen. The way you calculate it is you always take the total number of possible outcomes, or that sample space, and you put that in the denominator of a fraction, and you put the possible successes or successful outcomes of 3, which there's only how many successful outcomes of 3? There's just the 1. So you put the number of, they say, successes. So this would be 1 over 6. There would be a probability of 1/6 that you would roll a 3. Now, a lot of times they want to be able to know the probability as a percentage. So make sure you have a calculator and you know how to do percentages. So for instance, if I type in 1/6 on my calculator, I get this 0.16666, which means that I have a 16% chance or a 16.6% chance, or if I was to round to 1 decimal place, a 16.7% chance. So if it asks for the probability of rolling a 3 on a six-sided die as a percentage, I would say it's 16.7% chance if I was to round it to 1 decimal place as far as a percentage. Because remember, as percentages, we always move that decimal over twice. 1, 2. And so you'd put the decimal here and say it's 16.66666%. If you round it to 1 decimal place, you'd round that 6 up to a 7, since that's a 6. But they might not ask for a single event. They might ask for a combination. Like, for instance, they might want to know what's the probability of you rolling an odd on this six-sided dice. Well, how many odd numbers are there? There's 1, 2, 3 odd numbers. So the probability of rolling an odd would be 3 successful outcomes, 1, 2, 3 outcomes out of a total of 6. That would reduce to 1/2. A lot of times they will want the probability as a fraction, so you'll put 1/2. They want it as a percentage, that would be 50%. So let's actually start doing some from the IXL lesson. That's the only way you really get to see it, because a lot of times the wording is very important with what they ask for. So again, as we do this, just remember that the capital P here in this means I want the probability, and then in the parentheses is what they want the probability of, being a 3-year-old. So we got to read. Amelia runs a daycare center. Of the 14 children at the daycare center, 2 of them are 3 years old. So the question is, what's the probability that a randomly selected child will be a 3-year-old? So if it's just as likely to select any one of the kids as any other, we have a 2 out of 14 chance of getting a 3-year-old, because there's a total of 14 children. So you would do a 2 out of 14, and then make sure you always reduce your fraction. 2 out of 14 reduces to 1/7. Now over here it says write your answer as a fraction or a whole number. I think it's funny that they say fraction or a whole number. The only way you would ever write it as a whole number is if it was 100% chance, and that would be a 1. All your probabilities, unless it's 100% chance of being successful, is going to be a fraction. It's going to be 1/7. Okay? And again, the most important thing is reading the problems carefully. Here, I want the probability of something being blue. Well, let's see what's happening here. 3 out of 9 balloons in a bunch are blue. So what's the probability that a random selected balloon would be blue? Well, again, 3 out of 9 balloons in a bunch. So again, you're going to go 3 out of 9. You're going to reduce that and get 1/3, which will be your fraction. And again, I think it's funny they put a whole number. That would only happen if it was 100% chance, and you'd put a 1. Very rarely do you get a 1. Here we have a spinner. It says you spin the spinner once. So you spin it once. What is the probability of getting a 4? Well, if we look at this, we're going to always assume that each event is just as likely as any other. So this is divided into 4 equal parts. Only one of those 4 parts has a 4 in it. So it would be 1 out of 4, which doesn't reduce. It'd be a 1/4 chance. Here, there are 6 dogs at the park on a busy Saturday. 3 of them are dachshunds. What is the probability that random selected dog is that dachshund? So again, that's how this is read, the probability of being a dachshund. Well, it's there are 6 dogs total. 3 of them are the dachshunds. So again, 3 out of 6. And then I reduce that 3 out of 6. It's 1/2 chance, and it wants it as a fraction. So I type in 1/2. Here, a package of party favors contains 18 favors, of which 8 of them are party hats. What is the probability that a random selected party hat will be a party hat? So probability of a party hat, well, 8 out of 18. Again, on a separate sheet of paper, I do 8 out of 18, and I see how that reduces, at least by a factor of 2. 4 over, it reduces to 4 ninths. So I come over here and write 4 ninths. I thought by this point we would have gotten a percentage one. I just want to make sure you realize we will get percentages. Oh, here we go, a percentage. You flip a coin. What is the probability that you're going to get a heads? Now again, we're going to think that this coin either lands on the one side or the other. We don't land on the edge. I know some of you are going to be very technical, but let's just say there's only the 2 options. We either get a heads or get a tails, and they're just as equally likely. It's 1/2, right? 1 out of 2. As a percentage, that's 50%, or 0.5 is 50%. So make sure you convert that to a percentage. Don't make the mistake of not doing that. You pick a card at random. So apparently what they're saying is there's only 4 cards total. There's a card with a 2 on it, a card with a 3, a card with a 4, and a card with a 5. What is the probability of picking a 5 if you're randomly picking it, so you can't see them, you turn them over, whatever, and shuffle them up? Well, only 1 out of 4 is a 5, so that would be your probability, 1 out of 4, which doesn't reduce. Here, Isabel went bird watching and saw 28 sparrows, as well as 64 other birds. Now it's going to be a little bit trickier because you're going to think 64 is the total. 64 is not the total, as well as 64 other birds. The total would be the two added together. So on my sheet of paper here, I'm going to definitely find out what the total is. So the total, if I have a total of 28 sparrows and 64 other birds, that's 12, puts a 1 up here. That's 92 birds total. So your probability is going to be out of 92, and they want to know what is the probability of it being a sparrow. Well, how many sparrows were there? There was 28, so it's 28 out of 92, not 28 out of 64. Be very careful when you get to the ones that don't give you a total directly. I'm going to reduce that because they're both even. That's 14 over 46. That still reduces to 7 over 23. And I believe that's as far as it goes. So again, write your answer as a fraction or a whole number. I'm going to write that as 7 over 23. Now, a high school choir has 20 members, of which 8 are tenors. What is the probability the random selected singer will be a tenor? Again, probability of being a tenor. Well, there's how many total? 20. How many are tenors? 8. So it's going to be 8 out of 20. And we reduce that fraction. 8 out of 20 reduces to 2 over 4, or wait, that's not right. Divide by 4, 2 over 5. There we go. 2/5 is what it reduces to. So I come over here, type in 2/5. Right? You roll, here's our 6-sided die. You roll a 6-sided die. What is the probability? And this is the one we actually did as an example. It doesn't ask for a specific number. It asks for the probability of an odd. Now you have to kind of understand that a 6-sided die has numbers from 1 to 6 going up, a 1, a 2, a 3, a 4, a 5, and a 6. So how many of those are odd? Well, 3 of those numbers are odd. Out of a total of 6 possibilities, we get a probability of 1/2 of rolling an odd, 1/2. So be very careful that you understand the concept. Here, the tables at a wedding reception each have a centerpiece. The centerpieces come in several different colors. There's 26 that are lavender, 2 that are fuchsia, and 8 that are red. What is the probability that randomly selected table will have a red centerpiece? So we want a red, that's 8. But it's not 8 out of 26, it's not 8 out of 2, or even 8 out of 8. It's 8 out of all of them. So we have to add these up. 8 plus 2 is 10, plus 26 would be 36. So we get 8 out of a total of 36 centerpieces. Now that reduces, at least by a factor of 4, that's 2 over 9. So it reduces to 2/9. So we come over here and we type in, there's a 2/9 chance of getting a red. Here again, back to the head one, what is the percent, what is the probability of getting ahead? And it wants to write your answer as a percentage this time. And again, it's 1 out of 2, or 1/2, or 50%. You're going to get some repeats that should go pretty quickly. Here we have Damon's Pizza sells pizza by the slice for lunch. Today there are 88 slices ready for lunch, including 26 slices of mushroom pizza. So we got to be very careful we read this correctly. There are a total, today there are 88 slices ready, including part of that 88 is 28 slices of mushroom pizza. Now we want to know what's the probability of getting a mushroom pizza. Well, there's 26 out of that 88. Don't accidentally add those two together, because those two we're not adding 26 more. It says there are 88 slices ready. That must mean that's how many total there are. We reduce this, we get 13 over 44. I reduce by a factor of 2. Whoops, you can't see that. 26, sorry, there we go. 26 over 88. I reduce that by a factor of 2, get 13 over 44, which doesn't reduce anymore. So I come over here and write in my fraction of 13 over 44. Right? You spin the spinner once. What is the probability of getting a number greater than 8? So again, read very carefully. We want the probability of getting a number greater than 8. Well, 6 is not greater than 8, 7 is not greater than 8, and be very careful, 8 is not greater than 8. It wants it to be greater than 8. There's only one number out of the 4 that's greater than 8. So you type 1 out of 4. Here, a group of students in a communications course was required to start a blog on a topic of their choice. They chose the topic shown in the table: computer programming, 48, art, 4, politics, 4. What is the probability that randomly selected blog is about art? Well, how many are about art? Well, there's 4 about art, but how many are there total? This is the careful thing. You got to make sure you add these all up, because there's not 48 total, there's 48 plus 8 more, or there's 56 total. So I write in 56, and then I reduce that fraction of 4 over 56. I know 56 divisible by 4, so I get 1 over 14. So my fraction, or probability of getting an art blog, would be 1 out of 14, or 1/14. This one here says, what is the probability that we get a divisor of 72? So I'm glad we're getting to these. I want to make sure you understand what does a divisor means. It means numbers that divide into 72. Is 72 divisible by 5? No, it is not. So 5 is not a divisor of 72. Does 6 go into 72? Or is 72 divisible by 6? Yes, it is. So 6 is a divisor of 72. Does 7 go into 72? No, it doesn't. Does 8 go into 72? Yes, it does. So we either want a 6 or an 8. Those are the only 2 that are divisors of 72. So that's 2 that are successful outcomes out of a total of 4. So again, 2 out of 4 reduces to 1/2, which is 50%. So I come in here and I type in 50%. All right. Here you flip a coin. What is the probability of a tail? Well, we've done this one many times. It's a 50% chance. Here you pick a card at random. Now there's a total of 5 cards, a 4, 5, 6, 7, or 8. What is the probability of odd? Well, we got to think which ones are odd. Well, 5 is an odd, 7 is an odd. Oh, only 2 out of the 5 cards are odd. So we go 2 out of 5. And we submit. Last one, what is the probability that something's prime? So now we got to know what a prime number is. Well, is 2 prime? Yes, it's the only even prime. Is 3 prime? Yes. Is 4 prime? No. Is 5 prime? Yes. Is 6 prime? No. Is 7 prime? Yes. So 2, 3, 5, and 7 are prime, which is 1, 2, 3, 4 out of a total of 6 possible outcomes. So again, 4 out of 6 possible outcomes reduces to 2/3. So there's a 2/3 chance, which, by the way, is 0.66666. And it says write your answer as a percentage rounded to the nearest tenth. So that's going to be 66.7%. Don't make a mistake of doing 0.6%. You're rounding to the nearest tenth. So I'm going to type in 66.7%. And we have our 90, and we got our 4. If you have any questions, please email me or log on and let me know. And hopefully this lesson goes fairly simple and easy for you. And have a good day.